Thank you. Hello. Do you sometimes have that experience? You discover something on the net or hear it from a colleague where you think like, oh, I have to try that, spend half an hour. That half an hour turns into an hour and a day, and you're totally hooked and think like, wow, this is cool, this is magic. This is actually what graph databases did for me. So the main takeaway of this talk is actually that I hope to get you excited about graph databases so you can see actually what you can potentially do with them, come across it, and really lower the barrier, because it's really easy with Neo4j and Python to just try it. And so this is not a talk about how to get a production-ready system and everything to know about graph databases. This is really scratching on the surface and doesn't go deep. Still, we go through a lot of material. See me after the session if you have questions or want to talk further. And I think the slides will be uploaded as well on the conference website. So, day-to-day practice, I don't use graph databases at all. It's a hobby, but it's something that I really enjoyed, and that actually solved a lot of problems for me in terms of, hey, just put it together, scrape stuff from the web, and see what you can do in terms of analysis. Who here has not written a SQL statement or worked with relational databases? Lovely. So of you who have the hands up, who's a DBA? Are we lucky? No self-group after this session. So we're going to talk about graphs. And graphs aren't these pretty things, kind of like pie charts and what you see like in business talks, and here is our revenue of the day. The graphs we're going to talk about is more like this. The circles are nodes. The arrows are relationships. And between the nodes, you have relationships. And you define what the node is and how they relate to each other. It could be a user. It could be a computer. It could be anything. At this point, you're completely free to pick and choose what is in your graph. So if you're talking about graphs, we're talking about this construct. And I'm going to walk you through a few concepts that relate to that, then how we actually get Neo4j to work in Python, query it, and yeah, a few resources. So that'll be the gist of the talk. In real life, it looks more like this. Somewhere here in the middle, you see David Bowie, big red blob, and around him all the people he worked with, all the collaborations, and then other people who collaborated with these people, and so on. And the bigger the blob, the stronger the relationship, the more work they've done together. And this can be quite extensive. If you think of social graphs, Facebook, things like that, it could be millions of nodes. You can build database in a relational database that cover this, and you query it, but it gets quite complex. You will have a lot of joins, things like that. So where are graphs useful? Where does this all come in? As I mentioned, social networks, you can do impact analysis. Think of your technical network. Something goes down, server is gone, what is the ramifications in there? Route finding, typical thing. GPS, they do it all the time. If you've been to the previous talk on OpenShift and the convenience app, typical thing, how like, hey, find me the next loo. The app already knows kind of where the loos are all, knows where I am. Things like that. It's often used in fraud analysis. It's really powerful because you have all these diverse data sets and you try to match them up. And to line up schemas gets pretty hard. And you get pretty inflexible. So there are a lot of use cases. And if you look through, you come across, next video is something where you say, oh, similar problem. Maybe I want to try graph databases. That could be for you. So it's not only nodes and relationships. You want to fill it with more information and make it more useful. Because Neo4j, founded in Sweden, is nice to know, but then you want to have properties like, hey, what year was it? So you have to carry these attributes, and you carry them either on the relationships or on the nodes. And you can do that in various types. It can be strings, it can be integers, whatever. And Neo4j, because I just have it in here, is one of the NoSQL databases, which means it's schemaless. You just inject more nodes, and the nodes have labels. For here, Sweden could be country. You don't see that as an attribute. You actually know kind of, okay, there's a collection of nodes and they're all country. There's a collection of nodes, they're all users. And these labels are quite hidden, and that's one of the things kind of that it's hard to get your head around at the beginning, because you don't see it instantly. It's not always in your face, because this label, kind of like the what kind of node I am, what kind of relationship I am, is carried in the background. It's very powerful, and we talk about this a little bit later as well. I want to point out this wonderful lady here, Nicole White. She's part of the Neo4j team. She does wonderful blog posts, and if you go online, I ripped off a lot of her stuff. So it looks very similar. It was easier for me. All right, so data modeling. We're all familiar with SQL, relational databases. They're powerful. Nothing must have really changed for 20 years. They will stay around. But as I've illustrated, there are a few niches where you really want to use graph databases. So how do you get from one to the other? So by example, here we have our users. Typical user UIDs. Every user can have a channel. So ID 1, Bob's gaming channel. And then number 2, Bob's cute dog channel. They all belong to Bob. So you create another table and say like, well, user channel. User ID 2, Bob has channel ID 1, Bob's gaming channel. And user 2, channel 2, Q channel. So Bob owns these two. We map them here. And then other people, other users, subscribe to Bob's YouTube channels. So you have the subscription. So user ID 1 is, let's look it up, Alice. Channel ID 3, okay, Cooking with Charles. Okay, so Alice is following Cooking with Charles. What do we have here? User 2, Bob, 5, and Disco Dancing with David. So you can all figure it out. You can do that at scale. All wonderful. But how about doing it this way? I think as a human, this comes actually quite natural, because you define the users all as nodes. So all the brown greenish nodes, they're all our users. And you define the channels. It's a node as well, but I talked about tags, these labels. We just label them as channels. And on purpose, I didn't write this in the node, because I said kind of like, think of it as just sticking around the background. And then we load attributes on the different nodes. Name. For my blue channel, David's how-to channel. Then how do they relate? David operates Disco Dancing with David. And Bob is subscribed to David. It's exactly the same example as we've seen here, just managed a bit differently. And you can imagine, if we now introduce something that doesn't belong into user or channel, with tables, you extend your schema, you have to propagate that through, it becomes sometimes a bit convoluted and hard to maintain. Here, you just create another node with another label. Now, Cypher. If you're familiar with SQL, Cypher is the equivalent for this. To query a graph, you have to walk it. So it's a bit of a different concept. You have to start at some point and say like, all right, we started Bob. We find Bob, and then we say like, okay, what does Bob operate? And I'm going to show examples on this now. Cypher query language looks a bit like ASCII art gone mad. It's designed to be human-friendly, and once you accept the fact how it looks, here's a very simple hello world example. You'll see like the match statement, similar to your select. This is the pattern match, because if you're looking for stuff in a graph, you want to patch a pattern, and this can get quite extensive. I'll come to this in a moment. And then you return whatever you matched. So in this case here, it's a very simple match, and we say like, hey, we want all the channels. Bim, 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 bim. Match channel, return channel. And you carry like, it could be C, it could be something else. You can name it anything you like. It's like a variable. And you reuse that in your query. Same for users. You say, I just pick you at random. And gives you all the nodes for the user spec. Now, we want to find Bob. This should look familiar to you here. It's key value. Because you look for the name, Bob, as an attribute of a user node. And this gets extended more and more and more. So I'm not going through all the details and all the possibility you can do with Cypher, how you walk the graph. This is really a very basic example just to expose you like, okay, that's how you get started on it. Just to give you a little taste, this is now how do you find all the users that operate a channel? So you don't want the people who actually only subscribe to stuff. You actually want the makers, the creators, and people who run YouTube channels. So you do it like this. And this is where dimension with like ASCII art gone mad. The square brackets, they're the nodes. These are the relationships, and it's literally user, little line, operates, match, point to channel. So it's literally the error translated that you're looking for in the graph. This is the same thing, just a bit more efficient, because if I switch back, you see kind of like I'm getting pretty loaded kind of the return stuff. And the database engine is clever enough to sort it actually out for me. It's like, all right, you're returning these things, 3 things, so I give them to you kind of like array kind style. And so suddenly that changes. It's just a bit readable if you're starting off with it, but it gets very convenient, because here you do actually path matching. And you think more like P is my path, and I'm not thinking about everything in between. Now, here is an example of the shortest path, which is also a typical thing for graph databases. I know from here to here, where is the shortest way to my loo? Example from the previous talk. And how do you traverse that, and how does the engine figure that out? And it's actually pretty fast. This is actually where graph databases can excel, and where you get really into trouble with relational databases, depending on how you design them. This is the query structure for the match. Don't read it all. I just want to point out, it's like you're looking for a pattern, you filter it, you have a host of stuff to fudge with it, exclude things, and the typical like order, paginate, things like that, that return your query conveniently as you need it. Obviously, you not only can look for stuff, select it, obviously you can delete, insert, update, all these others. So I'm not walking you through kind of all that stuff that's also in the database engine. It's wonderfully illustrated in tutorials and whatnot, but this gives you an idea what Cypher looks like and how you kind of query for stuff. So a few good things. It's a really powerful data model, and the best tool actually to design your model is this, a whiteboard. You just scribble on it. You stand around with people and have the discussions. They're like, oh yeah, this is a user. And everyone thinks, oh, they understand what a user is and what attributes a user carries. But not necessarily when you then discuss them. No, I thought it relates like this. And you draw and figure it out. Once you figure that out, you upload the data you have and see how it actually reacts to your queries and what you can find out about it. If not, you change it. You're not so bound by the schema. It's easy to query. It looks a bit daunting in the beginning if you look at the query language. In Python, there are a few libraries around that try to map it, typical ORM style. So you actually only write Python stuff. It's still, some areas, work in progress. But yeah, if you prefer that stuff, you even don't really have to touch Cypher language. There are some weaknesses. It scales nicely vertically. Throw more RAM, edit, great. Horizontally, sharding and all that stuff is tricky. And if you really want to use that stuff in production, you have to dive quite under the hood and kind of what works and what doesn't. Storing big data, data blobs, not a good idea with that. However, what you can do is, who says you only have to use a graph database? Look it up, then point to whatever is your blob storage. And it's quite a conceptual shift, because moving away into the whole NoSQL land and no schemas, sometimes, yeah, you have to throw stuff overboard where you think like, oh, you have to have it this way. Right, how to get it? On Windows, it's actually really easy. So I picked Ubuntu, which is a bit trickier because it's an engine that's not based on Python. It's Java. Neo4j, J for Java. However, you get driver for almost any language on the planet. So you have to install the JDK. The links are in the slides, and again, on the web there is more than enough information to get you sorted. And once you download the community edition, you unpack it, and you literally just start the daemon, and you go to the web browser. And I'm going to show this for 2 minutes at the end of this, which is a very nice interface to actually play with the data and kind of what you've created. So this is what it looks like. And we're going to look at the web interface maybe now before I run out of time. All right, this should be big enough. So this is how the browser wakes up, and you also have, just to show you, the admin interface in the background. You see, no security, no password. So please, if you use it in production, do due diligence, not just throw it out there. There's a few things you have to take into account. Anyhow, so you have this panel here on the side, which gives you the node labels. Again, this is kind of like the types of node. And just saying like, okay, person, I've loaded up something. This is the demo movie database actors, how they relate to other actors, directors, and so on. And you see the nodes, and these are the indices of the nodes here. Not very useful. What do, you click on it, say like, hey, actually don't show me the ID, please show me the name. And voila, suddenly it makes a little bit more sense. I'm not sure, a bit hard to read, but you see actors' names in there in the bubbles. You can also see this as a table. That's just nodes with the attributes all returned. Here you have your relationships and how your graph looks. So if you want to actually see the whole thing, whoops, let's switch that. This is roughly how it comes back. Again, with these ones, let's switch them. And you get the movie titles. If you play further with this, you can actually store macros and say like, all right, I don't want to retype it all. Find Tom Hanks. You see, Cypher is loaded up here. You can play with it. You execute it, bang, and there you have Tom Hanks. You found him. You can say, okay, how to find Cloud Atlas? Match. Cloud Atlas. You see, you're looking for the attribute, return Cloud Atlas. All right, let's execute it. Easy. So to really get a look at your data and play with that stuff, this is a really nice, easy interface. Solve for hops. Typical Kevin Bacon problem. And this is a very underpowered machine. And you get all the relations maximum for hops in the graph. Let's say shortest path to McRyan, which is a bit easier to see. query, bang, here you are. So I really recommend, once you install it, the interface is there, play with the browser, and you get a really good feeling how that stuff works. And literally, I quickly show you. The only thing I did, here's the daemon, start it up, bang, go. So, how to play with Python and making friends? There are several ways, but again, this is just an intro talk, so I'm going to hone on the easiest. There's a really nice library, PyToneo. You do the typical pip install, put it in there, and this code doesn't really work, so don't type it in like this when you get the slides. But this is kind of the basic statements and what they typically look like. This is your default local host addressed to the DB, the API. This is how you get your basic object for the graph, and then Cypher query goes here. The queries you've seen, you just go verbatim in there, you run them, and returns you an object that you can further use. This is actively maintained, and I found it quite easy to use. The alternatives, and there will be more. Some of you do a lot of work with Django. And so there was work put in make this pretty native to Django. I haven't tried this myself, so I can't comment on it. I can't comment on Bulbflow, but it seems to be interesting, and especially Bulbflow, the community seems to be quite excited. REST API, there's stuff in the engine where you can easily query your endpoints and things like that, which I found quite useful. You go to the web interface and say, get DB data, because it stores internally that stuff as graph stuff as well. Voila, you get your endpoints. And convenience features like that, that once you actually got exposed to them, make it really easy to deal with. Current one is 2.1.4, and I really recommend if your distro or however comes with something else, you update with that. There's still a lot happening, especially convenient if you're starting off with it, the import CVS files, because you have comma-separated files. You just load them up, and you play with the data. It's wonderful for quick and dirty stuff. Dense node support. Sounds complicated, is not, but if you think of like a pop star having many followers, but not many mothers, and things like that. So suddenly you run into a problem, okay, many followers, but like other relationships not out there. How do you deal with that? How the engine is doing lookups. That has been vastly improved. New Cypher functionality. Some stuff got tidied up, and yay, OpenJDK 7, so you don't have to rely on Oracle anymore. Really good release notes and stuff, so all on the web. And yeah, great community, especially on Stack Overflow. These guys are really, really good in answering, getting back to you. Auckland has a meetup. I'm not aware that one is here in Wellington or somewhere else in New Zealand. Google Groups is mainly around discussions and meta discussions, and if you follow the Twitter hashtag, there's a lot of hints and stuff that is useful for anyone at any level. Please remember, if you ask around, put the version in, which programming language, because not everyone is using Neo4j with Python. A host of programming languages that are really nicely tied into it. Driver name, query language, and all that stuff. It's much easier for folks to help you. And yeah, definitely have fun with that. So thanks very much. And I hope I inspired you a little bit to use it and throw some data into Neo4j and play with Python.
We actually have time for some questions.
I had to sit all the way back here.
Hey, Holger. Have you had any experience with large volumes of data, talking hundreds of millions of nodes or billions of nodes? That's one question. And the other one is, does it scale horizontally? Is it masterless peer-to-peer, or how does it work?
There is a commercial offering which is Neo4j.com, and they run the enterprise edition that does high availability and other things. It doesn't scale too well horizontally. There are things kind of that you can do, and there are enough companies out there who use it kind of at scale. The good thing is kind of with the engine, the query time, for example, if you say like, hey, I have 1,000 users or 2 million users, doesn't really go up. I've seen one example where he said, okay, if you build this in a comparable relational database, your query with like 1,000 users goes around like 2,000 milliseconds. With Neo4j it was like 2 milliseconds. It didn't offer really the details on how they were measured, but then they ran the same stuff with 1 million users, and it's just at 2 seconds. So nothing there happened. It is designed for millions of nodes and connections and things like that. And as I said, it is still, I mean, it's a mature database. It's been around since 2007. Commercial companies, entities, I mean, on their website, they have like a whole list of, like a bragging list, who's using it. Lufthansa, like for fleet management and whatnot. So you can do it, but I don't think you can do it without the commercial help and some really expert advice. I found it also then sometimes in my experiments I shopped the database, and just the way I did backups, it was like snapshotting, but that gets quite expensive. I mean, it's a brute force thing to just like copy a whole database off the file system. There are better ways of doing it, but yeah, the devil is in the detail.
I was just wondering about transactional support when you're doing a lot of updates in one go. Can you be sure that they're all going to happen at the same time? They're all going to happen, or none of them are going to happen?
Yes, no, it is. They have thought about this, and it's in there, so it's asset, and you can't update kind of like one node and then suddenly comes someone else and you get a mishmash of things like that. Right. So yeah, no, that is in place and it's reliable.
Actually, can I comment?
Yeah.
More of a comment. Use bulk flow. I use it for Fork the Cookbook. We handle it fine. Use bulk flow.
When you showed at the very beginning a picture of your graph and you have types of nodes, but then you have attributes on nodes, and you appear to have types of relationships and attributes on relationships, is that sort of a question of your most important properties go as types and your others as attributes? How do you make that determination?
Let's go back. The tags is really to cluster your node, because a node is a node is a node. You don't have anything like to easily throw it into, let's say, it's family. Treat it like a class.
But I guess I feel there's a difference between user channel and name in your queries and so on.
Yes.
Do you actually put user, name has to be in little brackets, curly braces, user and channel don't?
Yeah, because the name is your key, Alice in this case is the value, and you can have many. I mean, obviously I named only here one, but let's say address, gender, things like that, and you just load more attributes like onto your node. However, different families of nodes can have the same attributes. So I can have a name for a channel, like here, as well as for my user node, but the channel name has a different meaning.
But you
so
can't be a user and a channel, for example.
No, you can't be a user and a channel, but you can relate them. And what you're allowed to do is also you can relate to self. There are actually use cases for that. Or, as this one here, well, one node can relate to many more. You can chain them. There's a thing also in Graph Database. How do you do versioning? Someone says like, all right, Alice changes address. So I want to keep actually some of the attributes around and snapshot it in time. And from this date onwards, kind of, this is the new address. So you actually need 2 user nodes for Alice. Which one takes precedence? And you still can query them. So you chain link them, and you can build constructs in there, and there are different schools kind of how you go about it. But that actually built a link chain of Alice's node so you can keep the history. The engine itself also, now newer versions provide something where you can do this globally, but I have no experience with that, so I'm not sure how well this will hold up.
Please join me in thanking Holger, and if you have any more questions, I'm sure you can grab him sometime later today.